Hi, my name is Jonathan Bennion. I had a question on a process called GraphRAG. This is a little bit of a hyped up process I kept seeing in my feeds probably around March of 2024. I started seeing all these posts about this thing called using a knowledge graph inside of a RAG process, which is where you augment additional information in terms of in the form of a file with any kind of an AI application, as opposed to fine tuning. You have RAG, and then GraphRAG didn't make sense to anyone I was talking to because of the nature of the trade-offs that you make of all these processes with RAG. A knowledge graph involves, in theory, if the document is uh, not static, it involves creating a graph every time you want to use RAG instead of a vector database. And I thought that's kind of expensive. It's a little time consuming. People are probably going to wait longer than 20 or 30 seconds unless the server is right in front of them or they have a really expensive system. So I thought it didn't make sense. If you search GraphRag, you'll find all this stuff telling you how unbelievable it is. Um, I read the paper. This paper actually is written by people that you presume are extremely good at what they do. But I didn't find any information on um, any specifics on how it lent to anything advantageous with all that work that it would require a developer to do. So I created this code that excuse me, gets into the comparison of graph RAG. I just used just a knowledge graph form of RAG. Used Neo4j with a vector database for RAG, so that I compared the two because a vector database is there's like 20 of them. They're all equally as fine. I'm sure people would argue some are faster than others for what you need it for. It's always kind of neck and neck. It depends on what you have compatibility with, basically, and what you're familiar with. So I created this comparison, and I want to walk you through it in the video relatively quickly. What this does is literally I used GPT 3.5 Turbo to create a knowledge graph in Neo4j. And then I had FAISS, the FAISS retriever set up with LangChain to with some sort of comparable chunking that I could find that as far as I could research, everything equal, at least as much equal as I could. Uh, Look at a RAG document that model's not trained on. So I took the June 2024 US presidential debate transcript, the President Biden and or President Biden and former President Trump debating. Of course, there was a lot of crazy stuff said. That's and people interrupting. It took all that, and I wanted to create ground truth from that, so that it could be evaluated up against and at least measured up against in terms of my both retrievers, coming from Neo4j, the other coming from uh, uh, FAISS, and for a vector database, and I wanted to compare the two, and then I wanted to further compare the two in terms of looking at it using a cipher query to retrieve versus the retrieval step that would be non-cipher. So what I did is I imported all my packages. You can see what I was using here: recursive character text splitter, FAISS. Yeah, this the standard LangChain stuff. Those of you that have used LangChain know these packages relatively well. Ragus is what I use to evaluate the all these stuffs: faithfulness, answer relevancy, context recall. It has to do with precision and recall of both the document being retrieved and the overall answer. So you have those two two measurements at each step, which I think is pretty helpful. Um, so then I had my Neo4j set up with a trial Neo4j instance. Again, um, using OpenAI for where I needed it. I created a graph structure here. I'm just going to run through the code relatively quick and then share the results. But I created a graph structure using cipher statements. Again, using GPT 3.5 Turbo to identify what those might be. And then I created a vector index as well which I found actually improved results when I compared a vector versus non-vector for Neo4j. I felt like the vector actually lent to most of its advantages when I the vector index portion of Neo4j. And then I just added the entities to the index, and then I set up my retriever step and set up my Neo4j retriever step, set up a RAG chain function, and then compared both the Neo4j RAG chain and FAISS RAG chain using one retriever here, one retriever there. And then, of course, I had to create ground truth from the same document using this code shows I used 3.5 turbo, which is actually okay because the retriever is the same in each case. The retriever is actually the retriever is different in each case, but the retriever is not going to be biased, or at least it's actually comparing the retrievers, the difference in retrievers for the same LLM. So it's not as biased as you think it might be in this case, even though it appears to be. Uh, uh, then I have just my RAGS evaluate function for context relevancy, faithfulness, answer relevancy, and context recall. And then plotted the results and found that faithfulness was improved on the Neo4j side a little bit, and then answer relevancy was actually the main metric that didn't seem to be increased when it came to Neo4j. So then I ran the same thing with my cipher retriever. So I wasn't using the vector database to retrieve. And you can see here, this is a little bit different. It's querying everything that was related to the next thing, which I researched as one of the advantages to knowledge graph is being able to retrieve the entities that are related to something else rather than the nearest neighbor aspect of FAISS. Reran everything against the same ground truth. I created a new plot down here, and I found this. This is actually my main finding, and I plotted this actually twice here. I don't know why. I'm just running through the code and what I did. But this is where it was closer in answer relevancy, so that you could see actually the larger difference. If you go up here, the difference is only just a kind of large when you look at the relative incremental gain there, but the relative incremental gain here is extremely large for faithfulness. So it improved faithfulness, which is actually could be compared to precision, which is like facts. So there was less misinformation when you use a knowledge graph. This could be, in theory, the same thing that everyone's finding when they use a knowledge graph in any application. So it doesn't have to have RAG. And so my point is, this is great, but this may not be worth the ROI when using RAG, especially if there's documents that are dynamic and not static. If they're static documents, it might be worth doing once, and then querying that, but you wouldn't use RAG for that. So it doesn't make a lot of sense still for me using RAG, even with this huge increase, because you can have someone waiting 2 or 3 minutes for their application to be right, which might make sense in the medical domain, and might make sense in the legal domain. But most oftentimes it's not going to make a ton of sense from an ROI standpoint, so be careful to look at that benefit. It is a large benefit though, and the answer relevancy doesn't hurt as much when you use the cipher. So that's what I found. I wanted to share that with YouTube and start a new channel. So thanks everyone for listening.